All right. Good morning. June 21st. Uh, we'll be doing a little more SQL today, but want to go back and let Dexter present his data analysis project. So take it away, Dexter.
Good morning, guys.
Morning. Everything okay there, Dexter?
Yes, I can't find my PowerPoint, so I have to open it up from my email.
Well, are you going to be in class for a little while?
Yes, sir.
Do you want me to go ahead and start and you can kind of go through that while I'm slowly going over group by and having and functions and whatnot? Or do you want to, you almost got it?
I think I got it.
All right. Over to you.
And how I share the screen again?
Like right now, I'm on my Zoom screen and I can see everybody's name. And if when I move the mouse, some icons come up at the bottom of the screen. And right in the middle, it says share screen.
Oh, okay.
And then I usually just pick entire screen, especially if I'm going to be using more than one thing. And then click like OK and it comes up.
Share. Can you see it now?
It's up. Yep. Increase of population in the United States due to abundance of water. Ah, good. That's a big deal in the modern era. Go ahead.
Yes, sir. My project was going to be about the amount of agriculture that increased due to the population in the United States, but I had to limit my variables because the website where I collected my data, it was so much that it was hard to understand what the variables were. And I had to lower my scope. But these are my sources. These are my sources. I got it from the Food and Agriculture Organization of the United Nations. The information was ready and available. All I had to do was do a limit my variables. And it's very accessible. It was like you were clicking buttons to make sure which ones you want. And most of the information was provided, showed about farming irrigation and natural man-made water in the country. I had to choose between national rainfall index, the surface water production internally, water sources totally external and renewable, and the total renewable water sources per capita. And that's the data I collected. It was kind of difficult because of the range in which they collect the information. So they did they only let you do 5-year span. They won't let you do 1 year. So it was kind of difficult to set up my chart. My chart, but I figured it out a little bit. This is what the chart looked like. I don't know if y'all can really see it. And the population for 2013 through 2017 is in this light blue. And that's the largest amount of population, and that's the renewable water. And that's the water sources, and water sources production internally, and the national rainfall index. I was watching the videos and I saw that my peers were having trouble with the x-axis. Luckily, the website I went to, it gave you options to where you can choose which variable is on the x-axis. So it made it a lot easier for me. In conclusion, although the data represented shows the population did grow throughout the years, information provided wasn't enough to prove the theory. Had to leave some of the variables out due to the complexity of the data collected. Also, information of the variables provided didn't change much, so it wasn't clear if the variables caused the population to increase. And what I learned, there are many different sources of data other than the ones I use. So finding sources was pretty easy. Data cleaning, it was difficult because of the complexity of the variables provided by the source. I had to filter through at least 40 different variables, which I think I didn't need, but I didn't know for sure. However, maybe there were variables I needed that I didn't know because lack of understanding of the data. And that's it.
Okay. Can you go back to the chart number 4? Have you got that in Excel, or is that from the website?
Oh, in Excel.
Can you did you post that to your assignment? I saw you posted some files. Did
Yes,
you
sir.
post the Excel?
Yes, sir.
Okay, cool. I'd like to look at that. What I'm thinking that because you have period data along the x-axis that right now looks like it's sorted. If you coincidentally, it's sorted in reverse chronological order from most recent to furthest back in the past. Yeah, looking at that, I'm wondering what it would look like to use a line chart that showed those variables that you have currently on the y-axis across on the left-hand side there.
Yes,
If
sir.
you used a line chart and then had those periods of time, Excel doesn't care if it's Q1, Q2, Q3, Q4. It's still a period of time that's going from the past on the left to the current or the future on the right, or from older on the left to newer on the right. I'm gonna goof around with that and see what it looks like to me. All right, cool. Well, thank you, Dexter. Any questions from the group before we move on? All right. And somewhere on your screen, Dexter, there should be a button that says stop share. Um, there we go. Cool.
You got it?
Got it. Back in control. All right. Okay, guys. Well, good morning, everybody. Not everybody's here. We're missing Chris and Edgar and Cameron. Huh. All right. Well, we're going to continue with SQL. We've got a couple more clauses and a great big category to cover functions, just like any other language, Excel, Python, anything. There are fantastically powerful functions. So that's what we're going over today, doing calculations, using functions to modify column values. And we're also going to do group by and having, two other clauses, main clauses in a SQL query. All right, so we'll get started here. Share screen, share my whole screen, nothing but the screen. Okay. Yeah, SQL calculations and functions. Okay, so calculations are just like in Excel. Calculations are pretty straightforward. You are using, mathematical operations to do something, but you can also, depending on how you look at the term, you can also use functions to calculate things. So we can do, any number of mathematical calculations as long as they make syntactic. Is it syntactic or syntactical? Anybody?
Syntactical, I would say.
Syntactical. Somebody Google it while I'm yapping. uh, somebody used the word ironical or something. Anyway, sometimes you can add the al at the end, and there's not really any need to. You're making up a word. That's neither here nor there. So we got all kinds of calculations we can do, and functions. So there's two basic families. You got arithmetic calculations, which are, this plus that minus that divided by something else. So you can create a calculated field. And then you have built-in functions, and that's where things get a little more complicated because of the way SQL operates. You have two families of functions, and the error messages I get will often say you did something, single row function doesn't exist, or group function can't, need something, or so you see these terms in there, single row and group functions, in the error messages, and you see it in the documentation. So I'll just go over what those are, and then I'm the last half of the day. I've got two. If you've looked, two sets of brain teasers, exercises to use this functionality, plus what we've learned so far coming to date. So yeah, arithmetic calculations, just like you would think. You've got the same order of precedence with multiplication, division, addition, subtraction, and you can do arithmetic calculations on numeric data types. We'll talk about this in just a minute. Dates, you can't add days to a date like you do in other databases. Not in MySQL anyway. That's just something you got to learn based on the flavor of database that you are using, whether it's Postgres or SQL Server or Oracle or MySQL, MariaDB, Access. There's a bunch of them out there. I'm just finding out now there's a Google. Google Standard SQL. If you're using Google Cloud Platform, and some of the companies that we work with are all in with Google Cloud Platform. All their analytics are cloud native, and they use BigQuery, is the big data relational database, and it uses its own Google Standard SQL. So good grief, there's always going to be a spin on it. But luckily, I would say there's I don't know, 95, maybe more % overlap when it comes to the standard SQL versus the little tweaks that these companies have given it. Okay, so yeah, there you go. Arithmetic calculations. So they're done at just like you would on any other field or column. So when you want to create a calculated column, you do that as you select that column. So if you wanted to select, like, the room capacity, 10% of the room capacity, and call it overflow or whatever, you would do that as you select that column. You would select capacity times 1.1 or whatever, to whatever the calculation is, as you are in the select field, their select clause, and we'll got some examples of that. For example, we're going to select max enrollment, which is the highest number of students you can enroll in any one course section. So we will cut and paste that in. But we're also calculating a field, dividing it by 2, and then we're aliasing both of those columns by putting a more meaningful word in quotes after the column. And especially if you're doing calculations, it will name the column. Let's see where we're at here. It'll name the column. Like, let's get rid of the aliases and show it ugly the first time. So we're selecting max enrollment and max enrollment divided by 2. And yeah, so now you get this crazy looking column header. And if you're exporting this to a CSV, you're going to want that to be a little more meaningful. So instead of typing it in, I'll just back up and repaste it. So we're calling max underscore ENRL max, and we're calling max enrollment divided by 2. We're calling that by half. So it looks a little nicer in your results down here, which will be your column headers when you hit export. Just keep that in mind. Okay, so that's an example of doing a calculation as on a column as part of the select statement. And here we've got a query that displays the course name, section ID, number of total credit hours possible, and then times the number of credits for the course. And this is important in a university setting. They do this, they collect these metrics, this data analysis, called production, credit hour production. And because they charge often by credit hour, by student, that's kind of their income, their money making capacity is this credit hour production. So yeah, we're going to select course name, the course section ID, CSEC ID. Now if you downloaded this, I think I got rid of a where clause. I think I got rid of my old school where clause joining syntax. Did anybody download this from the classroom and bring it up to go along with me? Any of y'all?
I did.
Is that true? Did it have the where where course section equals course ID and da, da, da. Did it have the old school where clause?
It has. Looks like it has the same one as you're showing. Oh wait, but it has the where. So yeah,
It does.
have the
Yeah.
old.
So the old school, and I'm trying to reform myself, right? I'm trying to be new school and cool. Good luck with that, Walker. So yeah, I modified this syntax to use the inner join. So here we're going to have another calculated field, and now we've got max enroll star credits that we are aliasing as total credits. So let's run that, and you'll see. So we got this column called total credits that is our the total credit hour production possible for these different sections, because they have different capacities, these different course sections. I guess it would be more more visible, meaningful if we added a column there, and but a lot of times you don't want to add every column that you are combining in a calculation, because it just muddies up your output. So we're calling that total credits, but here I'll run it again without that column alias. And yeah, max enroll star credits. It's just ugly. So that column alias is frequently something you're gonna want to remember when you're doing calculations. And again, any of the arithmetic, you can modify any numeric column using as complex math as you need to. And this shows that you can even, we're using two columns to mathematically derive a third column. We're using max enroll and credits to mathematically derive total credits. And that can get as complicated as you want to, but it does it for every row. So you'll get that calculation for each and every row of your output, depending on your where clause and how you limit your rows, how you filter your data, you will get that calculation for every row. Okay, moving on. Dates, yeah. When I did this one in Oracle, you did it a different way, and I had to re-engineer, re-wicker the course. MySQL uses functions, as opposed to, like, in Oracle, I think you can just say like date field plus 365 would add a year to a given date. But we do that in MySQL using a function. There's also a built-in function that doesn't require any parameters. It just pulls in the current date. That's very helpful, particularly if this is running not interactively like we are now, because you know what today is. But if you're running this as a script, and you need it to know the current day every time it runs, you would use the function sysdate. And here's another built-in function called date diff for the date difference. So this little query down here is going to return the difference between system date, which is today, and student date of birth in days. So we'll grab that one. And I think I verified all of my, yeah. So Miller was born 13,491 days ago. And there you go. And in a few minutes, I'm going to pull up a much more comprehensive list of those things. Yeah, single row functions. We've talked about them. We've used a few. Date diff. Remember, we concated. We use the concat function, which takes a list, from 2 to however many parameters, and concatenates those into a single string. So these are all single row functions because they return a result for each row. And this will make more sense when we talk about the group functions here in a minute. So single row functions return a result for each row of the query. Okay. Single row function examples. Here's another date type, day name. What day of the week does a date fall on? And this can be handy for any number of reasons. And there are many built-in functions. And I'll show you 2 different resources here in just a sec. Just want to get ahead of myself. So yeah, born on Simon Grundy, born on a Monday. Anybody seen The Accountant with Ben Affleck?
You know, it's pretty good.
I just watched it again on HBO Max. He says a rhyme to himself as a calming agent, Solomon Grundy, born on Monday. Yeah, I didn't remember that the first 4 times I watched it. Good movie. Anyway, so there you go. Day name of a date. You pass it a date. It tells you the day of the week that fell or will fall on. Projects into the future as well. So I want to make sure I'm not getting ahead of myself. Let me see where I'm at. So that's single row. Okay. Now let me bring up 2 different things. One, I need to post, which I will do on the break. That's that one. Where are we at here? And I had SQL. I will post I was going to and didn't get around to it, but I've got a cheat sheet for all SQL commands, like select and creating tables, altering tables, all of that sort of stuff. There are database level commands. There's, like I said, this SQL language is your interface to the database. It's how you create tables. It's how you modify tables and add columns. It's how you insert data into the database. It's how you delete rows from a table. We are just scratching just the surface of all the things that SQL can do. But this is and you can download a cheat sheet like this probably from multiple sources. This is the easiest one I could find to get a hold of. It was in PDF format. So we've got, data types cheat sheet over here. We have, and these MySQL functions are, except where it says aggregate are group functions, but these ones like date and time, we just use day name, right? Isn't that the one we just used? Day name, yes. So these date functions are single row functions that will do whatever they do for each row of your return, like we used date diff and day name. So here's this, and this isn't the definition of them or how to use them. That's going to be in your MySQL language reference or your Oracle SQL language reference guide. I'm just showing you some cheat sheets so that once you're fairly familiar, you just need to jog your memory. But over here, like in math, you can get the cotangent of a numeric field by using the COT. There's floor division. You don't use the the slash slash, like we did in Python to do floor division, we use a built-in function called floor, and you pass it a number or an arithmetic expression that resolves to being a number, and it will tell you the highest the largest integer that is lower than your floating point parameter that you sent it. And then you've got modulus, like we did in Python programming, log, all that arithmetic stuff. Now, what's a little more complicated are like statistical functions. I was spent a lot of time looking at doing a z-score, which is remember it's a number that represents how far something is from the mean of a group of numbers in standard deviations. So, your data within one standard deviation is what, 66% of your data. And if it's within plus or minus 2 standard deviations, it represents 95% of your data. And 3 standard deviations is 98.5. I'm going from memory here, guys. But so calculating z-score requires some of these mathematical functions, including what we're getting to here, some group functions like average. Average will give you the average of an entire column and give you one number. It seems like I just touched on this a little bit, maybe like in subqueries. But aggregate functions, are where you start to get what are what you called group functions. And then we've got our comparison operators down here. So this is a handy cheat sheet, and I will post this to the SQL folder on the break. So yeah, in the next section of my PowerPoint here, we're going to start looking at these aggregate functions, which operate differently than single row functions. Okay. Yeah, day name, and then yeah, reverse is one of those string ones. Oh, I got one other resource I want to show you real quick. Let me pop this in here and spell everybody's name backwards. Ha ha ha. You got Draknelb. Blanchard is now Draknelb. Yeah. So there are numerous string functions, date functions that let you that return a value for every one of your rows. And it can be, single row. You would think maybe it only works if your result is a single row, but it's not. It works on every single row that comes back from the database. So there you go. But I also wanted to show you really what's my favorite cheat sheet for these MySQL functions is in the W3 Schools website that we talked about, or that y'all did some exercises from, and we're going to do some more with our remaining time today. But if you go to that W3 Schools MySQL web page and go down, and click on MySQL functions under MySQL references, click on MySQL functions. And then they are grouped by their application. String functions come first. So this is how you would trim off extra stuff from the left or extra stuff from the right, or how you would grab a certain number of characters out of the middle of a character string, how you would measure the length of a character string, how you convert it to lowercase or uppercase. You can pad a string, like if you need to add star, star, star to the beginning of a field for whatever reason, you can pad it. You can spell it backwards. There's a what 30, 40 of them. And again, this is not the official language reference manual. This is a handy way to look at it. And this W3 Schools uses MySQL because it's open source, so it's free, so that they're not paying a Microsoft or an Oracle license in the back end of this thing. But you can find similar resources like this for those other databases that are not open source. So these are string functions. And the other cool thing about W3 Schools is that when you see one that, and you see the definition of it over here, position returns the position of the first occurrence of a substring in a string. You can click on that and you get this better, more, more thorough description of what it does, how to use it, the syntax, the parameters, yeah, what version it started being used in. And then you can do this, try it yourself. I don't know that I necessarily chose the best example here, but yeah, if for some reason you needed to know, you wanted to like, you could create an entire column that returns where in your data it matched, a certain search string. And the nice thing about this W3 Schools is you can click on Run SQL and it will interactively run that. So and you can modify it if for whatever reason you wanted to find something different. So say we wanted to find 00 in W3 Schools. Instead of 11, it'll be 6. So this is the functionality of this W3 Schools website. That's why I'm showing you this more than the position function. But yeah, those are, and I'll go back to my list. Those are the string functions. So you just got to kind of think of what it is you're trying to do, and then you're being presented with this toolbox. So it's just like a physical mechanical problem. You got a screw you're trying to screw in. Well, you look at the screw and you figure out it's a Phillips head and you grab the Phillips screwdriver and you go to work. That's exactly what you're doing with these software tools. Is you're being presented with a problem and then figuring out the best tool for the job. And sometimes you find out you don't have the tool you need in your toolbox. So here's some numeric functions. You can return, like if you have positive and negative numbers and you just need the absolute value, you can call a function. The arc, cosine, the ceiling. Remember we did ceiling and floor with Python. And then there's a modulo down here. Yep, the remainder. So like we did in that little Python exercise to find out if a number was even or not, something mod 2 should be 0. Pi is a built-in, almost like a constant. And you don't even need to say what like systate, these built-in system functions, you don't even need to put a table name. So there are some select statements that will operate. Select pi 3.14 down to 6 whole decimals. So you've got mathematic functions. Here again, we talked about date functions that were on that cheat sheet. Well, here's a more explanatory explanation. And then, yeah, advanced ones. I don't know if there's any of these that I even mess with. We'll be going over case. We'll be going over this one, but I don't normally mess with if. But here we got like, yeah, version of the database, the current user using the database. So there you go. MySQL functions, and those are all, or most of them are single row functions. All right. So good enough. Let's take a break and then we'll finish out talking about group functions that like take all of the rows that are returned and then do something to all of those rows to give you a single value. Almost like I think we used max and min in subqueries. Seemed like we were selecting we were doing queries that selected a single row. Well, we're going to go into that in more depth in the next hour. Any questions before we go on break? Good, Chris and Edgar. Good to see you guys. I haven't been looking at my camera view. Okay. Going once, going twice, going 3 times. Okay, guys. See you back at 9:30. All right, back we go. Group functions, otherwise known as aggregate functions, because they aggregate results. All of the rows will form a single answer, a single number. We'll see that in just a minute here. Okay, so yeah, single row functions manipulate each individual database record or row that comes back. But sometimes we need to group together records or aggregate. So when I said that was slightly incorrect, a group function, an aggregate, doesn't necessarily operate the same on all the records that come back, because you'll see you can use a group by clause that kind of separates them out by, you'll see. If you haven't used group by and having before, it's kind of like a where clause, but we'll see here in just a sec. You may want to display the total number of students who register for a particular course. And the next one here, group functions perform operations on a group of queried rows and return a single result. And this is the irony. Single row functions return multiple rows and group functions return a single result. So it can be counterintuitive, but that is, I think I explained why they were called that. Okay, and we can group that data as it comes back and filter it like a where clause. We'll talk about that. Like group by is kind of like a pivot table where you say, you know, I want a row for this category, for this column. Give me a row for each of the unique occurrences of a value in this column. That's my rows. Well, the group by and having is a lot like a where clause, where it limits the rows that come back. All right, so starting at the top, here is a very typical group function. Select the average of capacity from location, because you have no where clause. I'll pop back over to Workbench. And so this will give you one number based on that entire column, the average of capacity. There you go. So, and if you look on your, I uploaded that MySQL commands and functions cheat sheet to the SQL module in the classroom in Canvas. So you'll see that AVG is in aggregates. Yeah. And sometimes it's not consistent, but sometimes it seems like MySQL is objecting if there's, you see this space here between AVG and the parentheses and sending it the column capacity. It seems like sometimes it objects to that space. So I'm not really, I haven't figured out syntactically if that's a coincidence or there's some other factor. So yeah, average capacity, 33.3. And there are, as you saw, a dozen or more aggregate functions, group functions. Count is an interesting one. Average gives you the numeric average. Count will give you the number of rows that meet a certain criteria, and count can be really handy because you can use a where clause and whatnot to count the specific number of specific things. Go back over to, and there's two different ways to use count. Count of star is all rows, the number of rows that meet the criteria. So, how like you can select star from location and get all the columns. Count of star counts, all whatever, uses all the columns, and it returns the number of rows that that are returned by the select statement. So like for this example, count of star from it was 20. You see it says 1 row returned here at in your output window. But if you were to just say select star from enrollment, you'll see 20 rows returned down here in your output window. That's the exact, that's all it's using. That's all it's doing, is telling you the number of rows returned by a select statement. And again, that select statement, can have a where clause and subqueries and all that stuff. But it gives you the number, not the sum. We'll get to that. But count of a field name or a column, select count in this case grade. If you pass it a column name, it gives you the count of non-nulls. So we'll check that out real quick. Am I recording? I am recording, right? I'm screen sharing. Yes, I'm recording on this computer. Okay, so let's go back to Workbench. Pardon me. Let's see, plug that one in. And I wanted to show you count of grade from enrollment. And I hit Control Enter and execute that, is 12. There are 12 non-null grade values in that table. And I wanted to prove that. So I wanted to, instead of using the count, I wanted to say select grade from enrollment, where grade is null, not null, not null. "12 rows returned, A, B, 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 da, da, da. So there's 12, yeah. 12 non-null values. And then if we pull all the nulls, I think it's 8. Yeah. So there's 20 grades total. Select star from enrollment where grade is null. Yeah, there you go. So yeah, it all operates the same. It's trustworthy. You just got to decide which, if you want count of star, if you want count of a field or a column, because it matters. It drastically, depending on the nature of your data. Sometimes it's exactly the same because you don't have any null values in your column, but you got to be aware of how it works. Okay. The two count functions different. Count of star gives an integer that includes all rows of a table that come back from that select statement. And count of field name, yeah, gives an integer that are not null. Okay. And I think we beat this horse pretty well, right? But we'll keep going just in case. I always think I'm beating a dead horse, and I prove myself wrong. The horse is still very much alive and needs to be beaten further. Those of you that are horse fans are probably thinking, God, that's terrible. Use a different metaphor. So we got count of star where, I think, what is it, Ruben Sanchez? Yeah. Student ID is 5, is Ruben Sanchez. So count of star gives us 5 records in enrollment. So he's enrolled in 5, but he hadn't had a grade. He hadn't gotten a grade in them all. So if we substitute grade for the asterisk, not frayed, grade, and run that again, we'll see 3. So there's 3 classes he has not gotten a grade in, 2 that he has. Okay, group functions and some more examples. We got max. Put that back in there. So the maximum of a column. So the biggest number in the max and roll column is 140. And then I think we just do min, right? We can just change that. It's 30. So from 140 to 30. And then sum, yes, it's easy to, especially in a pivot table in Excel, it's easy to get confused between the count of, the amount of something, the count versus the sum of the actual values. So just remember what you're doing here. Select sum of capacity from location. But I wanted to show you I think I'll go off script here and have some fun just for a sec. Sum of capacity. So there's all told 433 seats available in our location, to include those little 1 and 2 person offices and whatnot. You can add a where clause, and you get the same. It's just like you would think. It's the sum of capacity from location where, and we'll say capacity is greater than 2. So instead of 433, we get 427, and that filters out your offices in the location table. So you can combine that. You can, let's say, there's not a range function. One of the statistical measures that's important to look at is your range of values, which is from the minimum value that you have in that column. Could be 10,000 rows, the minimum value up to the maximum value. So it's max minus min. So if you collected data and you had people's age was a column, and they ranged in ages from 20 to 50, the range of your data would be 30. It'd be 50 minus 20. So your range value is 30. There is no range per se function that gives you that calculation in MySQL. It's different. There is a range function, but it's used differently. But you can select the max. Select max of capacity minus min of capacity, and give it a, forgot my close paren, and give it an alias, because that's going to be really ugly, of we'll call that capacity range. So we'll get rid of our where clause so that we bring back all of the rows, so that we're checking the range of the entire data set. I think I got that right. I'm gonna, like I said, I'm off script. Yeah. Your range is 149. There you go. Max minus min. So you can combine these as long as you don't violate the single row group intention of the way the function works. All right, and now back to our shoe. Oh, sure enough, combining group functions. So we're going to do a query that gives group information concerning enrollment. So we've got the sum, average, min, and max. So you can put, like I just did, you can use them in an arithmetic operation like that, or you can just select them like I'm doing here. So since these are all aggregate functions, we're going to get one row back, and they will all be the aggregates. Okay. So let me run this, and then I'll go back to my notes, because there was so we're, get that back up on that line. There we go. So we're selecting the sum of max enrollment, the average of max enrollment, and the max and the min of max enrollment, but only for what did we say? Something in 2007, summer of 2007. So we will get a single row back, because those are all aggregate functions. Blam. And our range would be 50 minus 35, so 15. Sometimes that sort of stuff matters when you're calculating statistical measures. Okay, so that's combining group functions. Let's see what else we got. I got some notes here. Note that if we leave off the term, we get functions for all terms. Yeah, and then I was goofing around with this last night, and I made a note to myself, note that if you combine group functions with plain old columns, like not an aggregate function, you get some pretty arbitrary results. Which let me show you where my brain went last night. So what do we have in course section? Let me get a new select star from course section. Yeah, CSEC day. Let's add that to our other query. Let's say we messed up, and we're going to add CSEC day all by itself like that, which is combining a column, like the entire column, right? I mean, CSEC day has what, 14 different value, or 14 individual values of what, three different distinct types: Monday, Wednesday, Friday, every day, and Tuesday, Thursday. So if we accidentally leave out an aggregate function and do something like this, I want to say, yeah, you get this, this Monday, Tuesday, Wednesday, Thursday, which is a single value, right, out of the table, combined with these aggregate functions. So what it appears, it's unreliable. You don't do it. It appears to be the first one out of the database, but I don't even think that it's that reliable, because what are we saying? This is Monday, Tuesday, Wednesday, Thursday, Friday. It's unreliable. If you accidentally do this and leave a column in there, a single row, along with aggregate functions, you get an unreliable result. And so I was goofing around with that as I was reviewing my my slides last night, and it's, yeah, the best I could tell was you will get arbitrary results, unreliable results, unless, next slide, Don, group by. So here's yet another clause in your query that lets you group results by a column. So, for example, we might want to show results of one column grouped by another. So we'll that's the next part here. So let's see what our sum of capacity is for everything, for all capacities in our table. Get rid of that. Don't save. Go back to here. Okay. So sum of capacity from location. So that's gonna, without filter, without any data filtering or where clause or anything, it's gonna add up everything in the capacity column, 433, as we saw before. But what if we wanted to break that down by building code, which, remember, is bus and CR. We use the group by clause. So we're going to select building code by itself, right? Like we showed, along with an aggregate function, which gives you problems unless you group by the thing that you're not using in the aggregate function, which makes English sense, right? We're going to select building code and the sum of capacity from location, grouping by building code. So we're going to get the capacity for each distinct building code value in the location table. So College of Business has 170 total. CR has, which I can't remember what the heck that stands for, has a total of 260, and the library has a total of 3. And my next slide points that out in gritty detail. You must include a field in the select clause that is not a group function, or if you select a field that's not a group function, it's got to be in the group clause. So you can select more than one thing here, but you got to group by it. So if you've got a group function here and not a group function here, you've got to group by the one that's not in a group, not in an aggregate, which makes sense, right? Somebody tell me it makes sense. Anybody?
It makes sense.
Thank you. Man, you guys don't know how often I feel like I'm looking out my window in my office at the trees. I can't hear you laughing. I can't hear you groaning. No, there's no questions or anything. I'm telling you, this Zoom thing is tough on an old man. Okay, so we get that, right? If you are aggregating data, you got to tell SQL what you're grouping that aggregated data by. And we've got lots of examples and practice. So now we did that before, right? You cannot reliably combine a group function and a field in the select clause unless you put that field in a group by. Yep, we've already talked about that. Okay, so let's do another grouping. We are going to select the course ID, the day of the week, and the max enrollment, the sum of the max enrollment. And then, like I said, we'll group by these two fields that are non-aggregated functions, non-group fields. So I'll select that. And run it. So here we've got the course ID and CSEC day together, making kind of like a unique grouping. And then you've got your sum 50. I'm curious, going off script here. Look at that result. Now, if we only group by CSEC day, which would be wrong, right? What happens? You only get course ID 1, which is, like I said, unreliable. It works. SQL won't tell you you're screwing up there, buddy. But sure enough, your results will be wrong. So there you go. Not everything in these computer languages will get caught on a compile error. Sometimes they're runtime errors, and that's on the programmer to figure out why the logic isn't working. I would think that it would flag an error, because you never want to do that. You never, ever want to do what I have here. You would think that SQL would catch that syntactically, but there may be some application for doing that. I don't know. I would prefer an error message. All right. Everybody see that? Everything you put up here that's not in a aggregate function, a group function, has to be down here in the group by. And then sometimes you want to limit, filter the rows that are coming back. So like, let's go back to this. Let me plug that back in and run it. Fix it back up and run it. Well, what if you only wanted rows where the sum of max enrollment was greater than some value, or equal to some value, or whatever? So you don't filter this in the where clause. You filter this in what's called a having clause, which I think I previewed. So we're going to say having, and then that will filter these results. If you wanted to filter the results that fed these results, you would do that in a where clause. The having clause filters by these aggregated results. So when you say having, you're going to put the aggregate function in your having clause. Okay, so the having clause places a search condition on the results of the queries that use group functions. It filters the group data, and it syntactically it comes after the group by having. So having group function, like having max greater than, and then a value or something like that. That's your syntax for the having clause. So what we're going to say is, for example, having sum of max and roll greater than 35. So come back over here and we see 70, 60, 70, and 315 and 50 are all greater than 35. We've got 4 aggregate values that are 35. So if I say having, and I use the same group function as I do up in the select, right? Having sum of max and roll greater than 35. That filters out everything 35 and lower. Making sense? No?
Yes, sir. It makes sense.
All right. Thank you, Dexter. That was Dexter, right?
Yes, sir.
All right. There you go. So having, or the where clause filters your raw results that feed the group by. Having filters the results of the group by, and that can be different. Because I don't think I have an example here. And last night I was thinking, I need to have an example. And I typed one up in W3 schools and didn't save it. So I'm going to do it off the cuff, and we're going to do one together. Okay. So these, yeah, it uses the same operators, comparison operator, like anything else. The having clause uses the same comparison operators. Okay. Here is an example. Query that displays building code and sums of capacities that are greater, sums of capacities that are greater than or equal to 100. Okay, so I'm going to use this in here, and I'm going to punch it in. Control V and enter it. Okay. See, the sum of capacity is our group function in the select clause, and we're using the same group function in the having clause. Okay. So let me back up a little bit, and I'm going off script now. So let me comment that out. I put it. So we are selecting, actually, let's start all the way from the beginning. Building code and capacity. And if I forget where I was going, I'll go back to my PowerPoint. Okay, so let's select the building code and the capacity from location. I'll comment that out too. Okay. Semicolon. Okay, so the building code and the capacity from location. Okay, because we have rooms in here too. Let me, is it room in location? The room column? Yeah. So that'll give us all the information we're looking for. I'm kind of going at this from exploratory up to, no kidding, that fully aggregated query we had before. So we're going to select building room capacity from location. And that tells us that in the CR building, room 101, we can seat 150 people. And in room 202, we can seat 40. 103, we can seat 35. 105, we can seat 35. So that's our raw, all of our seating capacity data. Okay, so I don't care about individual rooms. So I'm going to just trust that my data is legit, and I'm going to get rid of room. because all I want to know is by the entire building. Okay, so now when I select building and capacity, I get the same values, but I lose room. Okay, so now I want all of the total of capacity for each building. So I'm going to add, I know I want the sum of the capacity, but I'm going to leave out the group and see what I get here. Yeah, because I don't have a group by now. I can't rely on what the heck. That's not all my building codes, but I've used a group function and a non-group column without a group by. And that's where you start getting, it works, you get results, but it's not right. So let's add our group by and get rid of our extraneous semicolon. And that's where we get what we had before, 170, 263. And if we add our aggregate back in, now we're going to filter out lib, right? Whoop, get rid of my extraneous semicolon. And we filter out lib. But what I wanted to show was a where clause in here. So right now, look at our 170 and 260. Let's, I need to get my results again real quick here. I want to use a where clause that filters the rows before we even get to the group by and having. So everything from location. So I want to say select star from, or select building code, some location from location, where let's see, what would be a reasonable where clause to filter some of these rows that isn't going to result in the exact same answer as the, with the filter with the having clause.
You could filter out some of those room numbers. and then that
Yeah.
was your
So like,
changes.
so let's say like where room number doesn't equal, is that what you're thinking, Seth?
Yeah, like if the room was destroyed or being worked on or something like that.
Yeah. So where room does not equal, let's say, let's go get some values here. Whoop. Yeah. Where room, so we got some stuff in the twos. We got a 2 in CR and we got a 2 in the library. I'm trying to think if I filter any of these capacities in that where clause, it may make the same answer. So let's filter out rooms that start with 4. Would that make sense? It might. Let's try it. Where room does not equal 4 something. Let's see what, so we had 170 and 260. We still got 170, 260. Let's use a specific room. Where room does not equal, what's a big room? 101. Let's see what that does. Let's say 101 is being renovated. 170 and 110. Woohoo! There you go. So that's an example of a more full query that includes a where clause filtering the rows that are summed in here in capacity. So we're only summing the capacity of all the rooms that are not 101. And then we're grouping by building code, and then we're filtering the capacity that's greater than 100 after you've done that. And it's called the order of operations of a SQL. The clauses in a SQL query execute in a particular order that can impact how things are filtered, how the query operates. It can affect performance, and that is in on the internet there, order of operations. Beg your pardon. Yeah. So this isn't the order that the clauses go syntactically. It's the order that that the database kind of resolves things. It goes out and gets the table from memory, and then it filters out rows where, and then it groups by, and then it filters the group by in the having. I don't know what function is. And then once it creates that in memory, it goes through and selects the columns that you have said. But this is the order of the things that are happening in memory. And then after it's selected the columns, it goes through and filters out the rows by distinct. So this is kind of advanced database architecture, but this is how these queries operate kind of in memory as things are happening. This is how the database resolves these things. But syntactically, we've got it going on over here. Select from, where, group by, having, and then order by, right? Let's try that. We got good old order by. I want to say that comes syntactically later or last. Order by sum of capacity, let's say cap city. And again, I'm freewheeling here, guys. I'm hopefully you're also asking these questions yourself. Order by sum of capacity, bam. So it reversed the default order, which was 170 or business first and CR second. So that's, you see where you're starting to get a lot of clauses in here. And then when you throw in, complex expressions and subqueries, I'm still teaching myself a little about common table expressions. And Seth pointed out you can use a select statement in the from to create something that's like a common table expression, a CTE, which is a temporary table in memory that only lives as long as the SQL query is executing. I was goofing around with that, Seth, over here. You can select, for example, building code, room, and then I added 10 to room, which is arbitrary because room is the room number. It's not the capacity. But so I'm selecting 3 columns here from a select statement. Select building code and room from location. Then you have to alias it, because when you do this subquery, it forms a table in memory that you have to then alias, because it doesn't know up here in the parent query that there's 2 things going on, that there's a subquery and a main query, and you have to have different table names for those. So that's why you have to use an alias up here. So anyway, this works, and it's selecting from a subquery, which to me is counterintuitive. And like I said, I'm still learning it. My son and I were talking about this for about a half an hour when he got home from work yesterday. When to use CTEs and what they're good for and everything. I've been watching tutorials, but sure enough, I never heard of this, but you can select from a select statement. And the thing in the subquery becomes this temporary table, kind of like it does in the where clause, kind of like it returns a group of rows or a group of values in a column that you can say, is it in, is some where something is in that subquery, or if it's an aggregate value, a single row, you can say where it equals that. But sure enough, you can use a subquery in the from clause. And that just really sent me on a Google rabbit hole.
It's pretty
Yeah,
cool.
Don.
I'm
You
sorry.
also, yeah, you can also use it in the select clause, which if you're doing things with math, like if you needed to use the average to do a calculation, right? Like if you needed to know the average of the entire table to then use that for a calculation in the select clause, you can put it in there, right? So I could do a select in the select clause that returns the average of the table and then use that in another calculation if I needed to there.
There you go. I'm trying to think. You got my wheel spinning, Seth. I'm trying to think of when you would put it in this, like now. Can you
Like
see my
if you
screen?
wanted
Okay.
to know, no, I don't have anything like built right now that I could just show you, but like if you wanted to know, if you got the average or if you got the total, then you could calculate like the percentage of, rooms in the building or something like that, right? Like if you had, or like the total capacity, like what percentage of total capacity is each of these things? Well, you need to know the total capacity of your entire like set, right? To figure that out, to get a percentage from that.
Okay. Yeah. And that may be also a good example of a CTE, of a call of a common table expression, because or am I off track, Seth?
I think you could do the same thing with the CTE. I'm just trying to think of a good example of how, because I know that you can use a select statement in a select statement to return something that you might need to use for, some mathematical operation you're going to do.
Okay. Can you think of even the most, let me get a new tab. Can you think of even the most simple example of that using our Northwoods database, just so I can see what we're talking about? Like select
Go back to the one we were just doing that had the sum, right? You had the sum of the capacity, right?
Yeah, there you go.
So if we wanted to change that to percentage, right? Like what percentage is each of those? And this is, I'm not 100% sure how to do this. Like
Okay.
I was working on it.
No, that's let's
so then put another thing up in the select, right? Like
so this is going to be like another column. So this
Yeah.
select statement will be a column.
it'll be
Like
part of a column.
Okay.
Yeah. So select sum capacity from location, right? And that should give you that should give you everything, right? Like the
Yeah. Capacity from location.
Okay.
So that column value, and it will repeat.
I don't know what'll happen if you try to run it right now.
It won't run. Like I got a red X.
Yeah. So
I'll have to look into it.
okay.
I since you mentioned it being in a from and you showed me that code, which I think the code where it uses a select statement in the from clause to create that temporary table, I think that's just another way to do a CTE. I think they made CTEs so that it would be perhaps more readable, maybe, but I'm not positive. But I'll have to look into this, when you would use a select statement in a
If you give
when
me a
you would use
second,
it.
I can give you like a
I will
link to
give you a
something.
second, because I'm gonna. Well, you may want to listen for the next 5-10 minutes because we're breaking for the day. But I wanted to show you guys the database at W3 Schools because I'm asking you to do some queries based on that database. Is that fair?
Yes.
And if you want to stay online when we break, that's fine. But okay, guys. So break. That's the end of single row functions and grouping and aggregates and group functions and whatnot. So I think I've given you all the information you need to complete the next assignment, which is today. SQL calculations and functions exercise. And let me edit that real quick to make it due today. I think I got to go to this assignments, SQL calculations and functions exercise. Due today. And if you don't, like I said, if you don't get them all done, don't worry about it. Just turn in what you got. And we're going to play with SQL some more on Thursday. Today is the 21st. So we'll make that due midnight tonight. And again, this is just to get it right in the calendar in the classroom. Work on this. Wrong year. Nobody wants to go back to December 2021. Say, whoop, what are you doing? Cannot be after course end. What the heck's going on here? June 21st, 2022. Today, there we go. Okay, so when you go to the modules in our classroom and you go down to relational databases and SQL, you will see an assignment. And in that assignment, there are two files, two Word documents. One, Northwoods, you use Workbench and the database that I've been using all day. The other one is at the W3 Schools website. So there's two groups of problems that give you plenty of practice on pretty much everything I've covered so far. And so, like I said, I'm only giving you back 2 hours. You may not get it all done, but please, I'm gonna turn on my camera. And I'm going to put my palms together and I'm going to say, please turn in something by 12:30 today. There's a couple of assignments out there hanging around where I don't know what's going on. So turn in something by 12:30 today, by the end of class. It may not have everything in there, and that's fine. That's perfectly fine. We'll have some more time on Thursday. There's just a few more things I want to go over, and then there's another database I want to take a look at so that you're getting used to diving into data and dealing with different situations in SQL, not just the same old. So with that being said, I wanted to show you the database in W3 Schools so that you're comfortable. What this is, if you've ever used the Northwind database in a SQL Server from Microsoft, this is an adaptation of that database. Very straightforward. What do we got? 1, 2, 3, 4, 5, 6, 7, 8 tables. So it's actually much condensed from the full up Northwind database that comes with like Microsoft Access. So this is it's just like our Northwoods database. It's very simple. Okay. And the way I don't have an ERD for it. I don't have a diagram for it. I've looked on this website and they don't, I've never found one. So the way that you work with this database is you click on the table name. Oh, the way I got where I'm at is anytime you click on, oh, good grief, let's go to anything. Anytime you click on try it yourself, regardless of what you're trying yourself, regardless of where you click on try it yourself from the MySQL information, you will get this MySQL try it editor version 1.0, and it's all the same. The code that it sticks in here will be different. But the actual functionality and the database over here and the run SQL button is all the same. Okay, so it's really simple to work with. The database is also fairly simple. So what you have is a like picture like a it's called Northwind Traders. So they're an import export company that has customers and employees and products. And I'll go through each table briefly here so that you're more comfortable with it, because half of the assignment today is using this database. So you've got customers, 91 customers, and here are the column names. So it's easy peasy to see what your database structure is. All of the linking fields will have, or as far as I think it's all, will have this ID next to it so that you know that that's going to be in some sort of a, it's a primary key, and it's going to be probably a foreign key in one of the other tables. So customer ID is the unique identifier for each separate, and you can scroll down and see all 91 customers, and it's very European in nature, very global. Okay, so you've got customers. Okay, you've got categories, and these are in alphabetical order, not necessarily by how they relate. You have categories of products. This is a lookup table, so that you know when elsewhere in the database you see category ID, this is what it's pointing towards. There's beverages, condiments, confections. So each category of products has a category ID as its primary key. You've got employees, just like you would think. Employee ID being the primary key. You got last name, first name, date of birth. I don't know how to extract this employee picture. I think it's just showing you that you could, you can store large binary objects like pictures in the database. And then you've got a notes field that you can use for longer string manipulation functions. Okay, so that's the employees table. Order details, let me come back to you real quick. You've got orders, and the primary key for that is an order ID. So you can see it goes from 10 to 48, 49, 58, 51. So you've got 830 customer orders in here. The customer order has each order has a unique order ID. Each order has a unique customer, and there's the customer ID from the customer table. Each order has an employee that placed that order, a date that it was the order was placed, and a shipper who's going to fulfill that order. So now let me go back to order details, because there you'll see like order number 10248 is in here 3 times, because we have 1, 2, 3 detail lines. So order detail ID is the primary key in this, and it's not a concatenated key. It is a standalone unique identifier, order detail ID, but it will tell you the order for that detail. It'll tell you the product for those 3 line items, because we're ordering 3 different products in order 10-248 and different quantities for those products. So that's your order details table. Products are like you would think. There's a product ID and the name. There is a supplier for that product. It has a category that you would go look up in the categories table. Tells you the unit of whether it's a case or one jug or whatever, and then how much that product costs. And then you have shippers that are purely a shipping ID, and then suppliers that supply different products. So you've got the supplier ID in your product. So product 1 is supplied by the Exotic Liquid Company. So it's a pretty straightforward database without a whole lot of surprises. And I don't do a whole lot of super complex joins or anything in this exercise anyway. It's mostly functions and grouping and whatnot. So those are your 2 different databases for the 2 different segments of the assignment today. That's all I have for you. Any questions or concerns?
I had a question, and it might just be preference, so it might not have an answer. But I usually, how you say like to turn in, I like turn in incomplete, and then I just finish it the rest of the day and like turn in the complete one.
Mm-hmm.
Do you want, because you were saying that we'll have like time on Thursday, should I just be done at 12:30 today then?
Yeah, because
Or okay.
I'll take a look at what you got this evening or tomorrow. What is troubling me is there's a few assignments that are going back now, and I don't have anything for them. And when I get nothing, I immediately leap to the conclusion that you were unable to do any of it, and I'm a horrible instructor, and I've completely confused you, and I'm useless. So if that's true, you should probably call me and let me know personally, as opposed to just give me a little hint, like not turning anything in. So yeah, turn something in by 12:30, especially for the folks that are attending. And Dexter, if you worked all night, I understand you and Cameron are in a different situation, but for everybody else, yeah, if you turn something in by 12:30 and kind of give me an idea where you're at. And then the usual thing, I'll be floating around the house. Text me if you need me. Email me any code that's not cooperating so that I can plug your code in and see maybe if I can troubleshoot it. So yeah, text and email me, not just in the next 2 hours, but whenever, if you need help or have a question.
Hey, Doc, I was wondering if you can I just posted something in the chat. That's what I was talking about last time we were speaking. The CTEs and this right here. And I was wondering, I've been struggling with that.
Row number over partition by.
It's for creating rankings in a column.
Let me jot that down. Can you give me more to go on? Row number, is that a function? Row number function?
Yes, sir. It's he use it to create a ranking of a certain column that has completed, processing, or failed, or queued. And the ranking is 1 for completed, 2 for process, and 3 for queued, and 4 for failed. And basically all these jobs get this in that column at a certain point in time. And I guess what the ranking does is it prioritize which status comes first when you try to query it or whatever. I
Mhm.
really don't understand what the ranking is for. I've been trying to understand. I've been researching it myself, but
Yeah,
I've been
that's
struggling.
that's what I would struggle for, is to get a definitive business rule for what it is they're looking for, and then attack the syntax.
Right.
But so what I'm looking at there, like, let me preview. Are you familiar with a SQL case statement?
That's another thing. I read it and I understand it a little bit. I don't know how to use it. You know what I
Oh,
mean?
okay, we're covering that on Thursday.
Okay, cool.
And to me, a case statement would look at values in a column and return something different based on kind of like if else logic in Python, which may be a way for you to assign a ranking based on a SQL case statement, maybe. But I don't want to get ahead of myself. But I'm going to go look up this row number function, but over partition by sounds like it might be unique to your database, right?
It might be. Yes, sir. Might be.
Okay.
No,
And
I know partition by is another keyword.
oh, it is a
Some-
SQL keyword. Yeah, I'm not familiar with that one at this level. But I've got that written down. I'll take a look.
Yes, sir. Thank you.
Okay. Sure. And again, I'm still teaching myself CTEs and trying to get it locked in. It takes me a little while. Like, I think I got VLOOKUP. I think I've seen it enough times now where I get how it works and how to use it. But CTEs, the one example, like Seth, the one I emailed you, and I asked him, why would you write that? It was from a tutorial site, and it was using a syntax of putting I think it was using the select clause in the or a subquery in the from clause. And it just didn't make any sense to me why you would ever do that, why you would do that in that circumstance, certainly, as opposed to the way I rewrote it and emailed that to you. So yeah, I got to see stuff like anybody else. I guess I got to see stuff a few times. It would help. You're all, if you're I'm 58. If you're my age, let me know. But I think y'all are much younger in your careers than I am. This is a philosophical note. It has nothing to do with anything, but there may come a time in your career where you have to make a scary choice, like I did. And that is, as you increase your responsibility and your position and your authority and everything, you get less and less opportunity to use these tools and stay, no kidding, focused on these individual tools and how they work. Seth, I'll pick on Bumper to Bumper. Patrick Celeste, the CIO at Bumper to Bumper, cannot spend a whole lot of time staying smart on SQL queries, even though there are people in his organization highly reliant on that, highly expert at it. The higher you go up in responsibility, the less you can stay in touch with these tools at some point. Some people manage it. Some people will only go as far as they can, or as high or whatever as they can, as long as they can still spend at least like 2 hours of their workday, no kidding, coding or whatever, because they absolutely refuse to become that manager that used to know what they were talking about, like me. My way of staying technically competent is to learn this stuff well enough that I can teach it. But the weakness in that is that it's not real world. It's not, it might be realistic, but it's not real world application. And that it bugs me. I just wanted to share that with you guys and let you know that it bugs me that I don't have hands-on experience with these tools daily, like y'all do. That's why I love helping with real world issues at work, because that's the only chance I get is helping you guys mess with something either in your project phase or just as an aside. If there's, and if you can, that's the difficulty, is if you can share the data with me, that's the problem. You very often can't, so we have to talk in generalities. So thank you very much for letting me get that off my chest. I feel so much better. No questions, concerns? Going once, going twice.
Hey, I put that link in the chat for that select query.
Do Geeks for Geeks. That's a good one. Select all. Whoop. Nope. If I click on that, did it? Hang on, I'm looking at a browser. Got it. Cool. Geeksengine.com. I will take a look, Seth. Thank you. All right, guys. I'll see you back Thursday morning at 8:30.
Thank
See you later, Dr. Vogel.
Thank you.
Then, thank you.
Thank you.